Start of presentation. This presentation will explain Neo-climatology from the perspective of meteorology. Neo-climatology shows us how mankind is causing global warming. Next. Neo-climatology originated from atmospheric chemistry and is the result of a historical process. Neo-climatology has a very strong model community that believes in first principles, equilibriums and forcing. Let us look at the historical process behind neo-climatology. Next. In the 50s, the testing of nuclear weapons increased radioactivity in the atmosphere. In 1963, the Partial Test Ban Treaty banned the testing of nuclear bombs in the atmosphere. Next. In the 70s it was discovered that the forests in Europe were dying, and it was thought that this was caused by sulfur dioxide, released by the coal-burning industry. In 1979, the Convention on Long-Range Transboundary Air Pollution was signed. However, it later turned out that the forests were growing, but acid rain was still killing aquatic life in the rivers. Today we know that decidifying rivers has little effect on aquatic life. Next. The ozone hole in the Antarctic was discovered in 1985. Models showed that the ozone layer was dissipating due to CFC emissions. Mankind was destroying the protective ozone layer, and this would eventually cause serious worldwide health problems. In 1987, the Montreal Protocol was implemented, which banned the use of CFC gases. The protocol predicts that the ozone hole over Antarctica should disappear in 60 years. In 2019, it was verified that the ozone hole is recovering and the Montreal Protocol was celebrated. Note that the observations that did not agree with the recovery model were removed from the verification. In 2020, there was a large ozone hole over Antarctica again, but NASA now said that it was smaller than it would have been without the Montreal Protocol. Next. Leading up to 2000, there was a call to stop carbon dioxide emissions, since it was causing runaway global warming. A strong correlation between CO2 and global temperature had been observed. Climate models indicated that increases in greenhouse gases were driving global warming. In 2010, there was consensus among the neo-climatologists that CO2 emissions must be causing global warming, and continued emissions would trigger a runaway global warming scenario. In 2015, the Paris Agreement was signed by many countries. Net CO2 emissions should be reduced to zero by 2050. The prediction was that this would keep the increase in global temperature below 2 degrees. In 2017, it was established that the El Niño global temperature anomaly gives an increase in carbon dioxide. In 2020, the CO2 levels showed no effects from the pandemic shutdown, but this was explained by the cancelling effects of the 2019 El Niño. Next. Atmospheric chemistry can be characterized as a science with no natural sponsors, which focuses on running computer-intensive models. It recruits personnel from the theoretical chemistry community, which applies quantum physics to formulate the most precise models on the planet. Observations are not necessary in quantum physics. First principles can be used as complementary information. In chemistry, systems usually have an equilibrium that can be affected by some external forcing. There are almost no observations in atmospheric chemistry. Next. Oceanography also has no natural sponsors, and focuses on running extremely computer-intensive models, much more intensive than atmospheric models. Oceanography also has almost no observations. Next. Meteorology is well funded. Weather forecasting applies complex forecast models and data assimilation systems using the largest computers on the planet. The forecasts are continuously verified using new and independent observations. So-called yield discipline is not necessary. You do not have to tell your colleague that he is wrong, you just have to wait for the weather situation to catch up with his prediction. The models are based on governing equations, and some parameterization of the complicated subgrade processes. First principles are never, ever, used. A meteorologist will say that the atmosphere has inertia, but that it is not in a state of equilibrium. Numerical weather prediction systems process billions of observations every day. Meteorology is known as the science of small steps. Even the most innocent assumptions can turn out to be false, which incidentally is how meteorologists discovered chaos theory. Probably more than in any other science, anything that can go wrong will go wrong in meteorology. Next. First principles are assumptions that are so obvious that you do not have to verify them. Neo-climatology is based on first principles. For instance, the total amount of carbon in the atmosphere Sea-Earth system does not change. Another first principle is that the average carbon flow between atmosphere and the Sea-Earth is zero. As a consequence, the CO2 trend must be caused by the burning of fossil fuel. An important first principle in neo-climatology is that climate models do not need to resolve short-term weather processes, since focus is on large temporal scales. There are of course arguments to support the first principles, but no proper verifications are available. Meteorology never uses first principles, and all assumptions have to be verified. Next. Neo-climatology has a strong model community, and no opposing observation community. The strong consensus in the model community shows that the model predictions must be correct. Observations are irrelevant if they do not agree with the first principles and model predictions. Observational sciences, like geology and economy, are openly disrespected. Meteorologists divide scientists into two groups, the model people and the observation people. When model and observation disagrees, the model people will say that the observation is wrong, while the observation people will say that the model is wrong. Of course, veteran meteorologists are aware of these fallacies and try to remain objective in their analysis. A major problem in meteorology is to find an optimal balance between model and observations. Next. In model parameterization, a complicated process in the system is replaced by a simple statistical relationship. Parameterization is necessary to solve any meteorological problem at hand, and you will find it in all meteorological models to some extent. In neo-climatology, the entire daily weather process is parameterized. There are no side effects of parameterization, since the parameterization is based on a first principle. In meteorology, subgrade processes are parameterized. However, a great concern here is that parameterization also removes nonlinearity from the model. As a result, the model predictions are less chaotic, and significant efforts are put into compensating, so that the model captures unexpected developments in the weather situation. Next. To summarize, neo-climatology relies heavily on first principles. It has a very strong model focus. Observations that disagree with the model, or first principles, are irrelevant. Neo-climatologists are not concerned about the side effects of parameterization, and believe that the atmosphere has an equilibrium that is changed by external forcing, like carbon dioxide emissions. In meteorology, all assumptions must be verified. Meteorology has a strong model and observation focus, and puts lots of efforts into achieving an optimal balance between the two. Efforts are also put into compensating the effects of parameterization. A meteorologist would say that the atmosphere has inertia, but that there is no equilibrium. Next. From a meteorological point of view, neo-climatology could appear to be out of balance. It is dominated by model people, and first principles are never questioned. Neo-climatologists think a lot like theoretical chemists while doing meteorology. Non-scientific arguments are also accepted to resolve scientific problems. Neo-climatology has a large impact on society, despite a poor track record. Next. The neo-climatology imbalance is the symptom of an imbalance in the representation of science in the media. This underlying problem should be solved first. Traditionally, Academic freedom has ensured that the public have been given a balanced representation of science. Academic freedom has eroded since the 70s, when a market for science was created, through project funding mechanisms. As a result, scientists raise awareness of their research in the media. This raises public interest, which gives more funding. Scientific information should only be conveyed to the public, by scientific parties that have no investment in the public opinion. Next. Thank you for your attention, and stay safe. End of presentation.